everybody. In this video, we will be talking about arithmetic series. So before we talk about arithmetic series, just one particular concept we want to talk about first, which is what is an arithmetic sequence. So let's first go ahead and talk about that. What is an arithmetic sequence? Okay. So sequence essentially is just a list of numbers where there's a constant number essentially adding to get to the next term, right? So one example right here is I have 4, 9, 14, 19, 24, and 29. As you can see, if I were to take a look at the common difference between them, so to get from 4 to 9, I need to add 5. Okay. Same thing over here, I need to add 5. 14, 19, same thing, we need to add 5. And I continue this throughout my sequence. Right? So because I'm adding a singular number each time per term, that tells me that this is going to be arithmetic sequence. Okay, so there's a few components to an arithmetic sequence. One thing we could do is figure out what is the equation that describes the relationship from term to term. So I'm going to define a few variables here. One of the first ones we have is D. Right? D represents the common difference. Okay. So in this particular case, in this sequence that I have here, I can say that our common difference is 5. The next variable I want to define is A sub 1. Okay. So A just represents arithmetic, right, or just a random variable, and this one here talks about essentially the first term in sequence. Okay, so in this particular case, if this is my sequence, the first term is going to be 4, so I'm going to make that equal to 4. And then the next one we have is A sub n. So in this case, it represents the nth term, right? So in this case, I have 6 terms, right? So A sub n could be A sub 1, which represents the first term. If n is 2, that gives us the second term. And if it gives us the 6th term, A sub 6, that's going to give us 29, correct? So typically, you can consider this the last term as well. Okay, because n typically stands for the number of terms. Okay, so if I go back a little bit, A sub n in this particular case is 29. And n, like I said, is a number of terms, which in this case is going to be 6. Because I have 1, 2, 3, 4, 5, 6 terms, correct? So now, because there's a constant number I'm just adding by, you can think of this as like the slope. So if I wanted to relate these components to create an equation for our sequence, we get this. A sub n is equal to D times n minus 1 plus A sub 1. And this is how we get the equation of our sequence. So if I wanted to find the equation for this sequence, it would be like this, right? So D we said was 5. So let's start off with the A sub n first. 5 is our common difference, which is the D. N minus 1. And then a sub 1, which is the first term, is 4. So we can use that equation. If you want to simplify it so you don't have the parentheses, you can simplify it further. So 5n minus 5 plus 4. Therefore, you can say that another possible equation for the sequence is 5n minus 1. Okay. So these both are possible sequences to our equation, to our sequence here. But you might be thinking, arithmetic series, that's the main topic, right? So what an arithmetic series is essentially is the sum of an arithmetic sequence. Okay. So essentially, if I wanted to find the arithmetic series of this above sequence, I would write it like this: 4 plus 9 plus 14 plus 19 plus 24 plus 29. And adding these 6 terms together will give us what we call the S sub n, right, of this sequence. So in this case, this gives us 13 plus 14, that's 27. This gives us 46 plus 24, that's going to be 80 plus 109. Okay, 13, let's do that again. 13 plus 14, which is 27, plus 19, which is 46, plus, this should actually be 70, plus 29, so it should actually be 99. Okay, so there should be a few ways we could have done to solve this. Okay, so there might be times where there's a ton of terms, right? So one way we can do is we can model it using a graph. Okay, so let's say we have 4 over here, we have 9, 14, 19, 24, and 29. Okay, and then we have 1, 2, 3, 4, 5, 6. So here I have a graph, essentially, that plots all of our data into a graph. Okay. So one way we can visualize this is if we were to calculate the area of this shape, that would give us the sum of our sequence. But one thing we can do is, let's try visualizing this by trying to create a shape that's really easy to find the area for. So one thing we can do is we can stack this last term here with the first term. So we're going to add 4 to 29, thus giving us this shape here. Okay. Do the same thing for the second to the last term. It'll give us this shape here. And then this shape will stack on top of this last term here. And as you can see, because they moved, essentially it makes a new shape. It essentially makes a rectangle, right? So in this case, this essentially is disregarded. So now we just need to deal with this rectangle. And to find the area of a rectangle is just the length times the width. The length here is 3. And the width here, so if we add 4 plus 29, that gave us 33, which essentially gives us 99. Okay. So remember, how we got 3 was essentially we had our total number of terms. So we had 6 divided by 2, because we had 6 terms, we halved it. And this 33 came from adding the first term to our last term, which still gives us 99. Right? So essentially, a formula that we can use to find the arithmetic series is this. We have our number of terms, n, divided by 2 times the first term plus the last term. And that's one way we can find the arithmetic series of a sequence. But of course there's a few other ways we can do it, right? So one example here is earlier we figured out that the equation of that sequence was 5n minus 1. Okay, and one way we can visualize a series is through something called summation notation, where in this case it looks something like this. In this case, let's make this k here, and we have, in this case, we have our arithmetic sequence, which is 5n minus 1. Okay, so in this case here, k just represents another variable. So in our case, since we had n equals 6, right, I can write it like this: n equals 1 to 6, 5n minus 1. So what that tells me is that I'm essentially going to sum all the possible terms starting from 1, right? So that's our first term. I get my second term by plugging in the 2. I get my third term by plugging in 3. And then I continue this until I reach my very last term, which is 5, 6, minus 1. And as you can see, it's essentially going to give us the original sequence that we had earlier. This ends up giving us a 4. This gives us a 9, 14, plus 19, plus 24, plus 20. So that's just one way we can essentially write it. So to figure out summation notation is we need to first figure out what is our sequence equation and where do we start. We start at first term, and this is where we end at the 6th term. Alright, so that's one way we can read summation notation. So when we see this, essentially all we need to do is figure out a sub 1 by plugging in 1 into our equation of our summation, which is 4. A sub n, which is essentially this last term, which is 6, minus 1, which gave us 29. Right. And as you can see, from 1 to 6, this actually tells us how many terms are in our sequence. So if we're going from 1 to 6, that tells us that we have 6 terms. So using our formula again for arithmetic sequence, I get 6 divided by 2, 4 plus 29, which gives us 3 times 33, which is 99, which is what we had earlier. So that's a few ways we can visualize an arithmetic series. So let's go over a couple examples here. So let's say I had a first term is equal to 33, my last term is 339, and our number of terms is 35. So essentially we figured out that the equation for a series is the number of terms divided by 2 times the first term plus the last term. So in this particular case, we would get 35 divided by 2 times 33 plus 339. Right, got some large numbers here. So in this case, this would give us 17 and a half times 33 plus 39. So it's going to be 372. Right. So multiplying these two together, let's do some quick calculations here. We have 17.5 times 372. We end up getting 6,510. And isn't that a lot easier than us adding 35 separate numbers? That definitely is, in our case. Okay. Right. So now let's go ahead and take a look at the next problem. This one uses summation notation. So in this particular case, like I said, all we need is the first term, we need the last term, and we also need our number of terms. So to get our first term, all you need to do is plug in 1 into our equation. 5 times 1 minus 7. This gives us negative 2. And then for the last term, we plug in 15, because this determines what is the last term that we're going to plug into our equation. So it's 5 times 15 minus 7, which in this case gives us 75 minus 7, which is 68. And our number of terms in this case from 1 to 15, that's 15 terms. So using our equation again, we end up getting 15 divided by 2 times negative 2 plus 68, which gives us 7.5 times 66. And if we do some quick calculations, we end up getting 495 as the sum of the arithmetic series. Right. So that right there is essentially an overview of what arithmetic series is. It's just if you have a number of terms in a sequence, add them together, that is what we call the arithmetic series. And this is the equation that we use to define or to evaluate the arithmetic series. Thanks for watching.